We are delighted to continue with our series of research paper presentation where we will be hearing from scholars and academicians sharing their valuable work, wishing all our authors the very best. Let's look forward to an insightful and enriching session ahead. In this session, each participant will be allotted 8 minutes of present the research paper. We kindly request everyone to be mindful of the time to ensure a smooth and timely flow of the session.
Before we begin, it is our pleasure to introduce the session chair for this segment, Dr. P. Naresh, will be guiding us through the presentations. We thank you, sir, for joining us today. Dr. Pannangi Naresh holds BTech and MTech degrees in Computer Science and Engineering from JNTUA, Andhra Pradesh, and a PhD from Weltech University, Chennai. He is currently an associate professor in the Department of CSE at Dayananda Saga University, Bangalore, with 15 years of teaching experience. He has published 39 papers in international journals, presented at 25 international conferences, holds 5 patents, and authored 6 textbooks. He has also edited 2 book chapters. Dr. Naresh serves as a reviewer and editorial board member for SCI, Scopus, and journals. He has also been a reviewer and session chair for multiple international conferences. He is certified in Data Science R Basics from Harvard University and Database Design and Programming with SQL from Oracle, also serving as a program instructor at the college level. He has organized and participated in various FDPs, seminars, and guest lectures. He is a senior member of IEEE and a member of IAENG, CSTA, ISRT, and ISCSES. His research interests includes data mining and big data analytics, information engineering, and machine learning.
Now I would like to introduce our internal chair, Ms. Pooja Kulkarni, Assistant Professor BE MTech CSE, pursuing PhD in Machine Learning from Visvesvaraya Technological University, Karnataka. With experience of 13 years, Ms. Pooja Kulkarni wrote 6 research papers. She also presented Capsule Network and also published Taylor and Francis Jan 2025 at Manipal University Academy of Higher Education, Bangalore, in code AI 2024. Study and analysis of FIDO2 password-less web authentication at Springer PP 375-386 in 2024.
Now let's proceed with the presentation. Our first presentation is by Bharat Kumar Parla from Guru Nanak Institution's Technical Campus. Team Bharat Kumar, please begin your presentation.
Good morning, one and all. This is Tarun of CSE1, roll number 518. I am we and Bharat are a team. So we came here for the paper presentation of the title Bypass Statics in Textbook-Based Communication Systems. Okay, our teammates are Bharat, Ashdit, and me, Tarun, under the guidance of Rajeshri Ma'am, who is Assistant Professor of CSA.
Yes, Bharat, Are you there?
Yes, sir.
Yes, carry on, man. Mr. Bharat, you are not audible, man.
Okay, coming to the abstract, this study presents an advanced SMS spam detection system utilizing the long-term memory, which is also known as LSTM networks. Here, a new SMS dataset compromises 61% legitimate and 39% spam messages was introduced, representing the largest publicly available dataset to the date. A comparative analysis of a machine learning models revealed that traditional approaches are susceptible to evasion techniques. The LSTM model demonstrated super performance achieving 98% accuracy in spam classification. Despite high accuracy, certain evasion strategies remain challenging, emphasizing the need for continued research in robust spam detection systems. Next. Coming to objective, to develop an efficient SMS spam detection system using the machine learning, especially LSTM networks. Create and utilize a comprehensive SMS dataset to enhance spam classification accuracy. Analyzing the evolution of spam SMS and detection, identify vulnerabilities in existing detection methods. Compare the performance of shallow machine learning models and deep learning approaches to improve spam detection accuracy while addressing evasion techniques. Now, introduction. Okay, SMS spam is a growing issue, with spammers using advanced techniques to bypass traditional filters. Conventional methods often fail to detect, leading to security risk and user inconvenience. Machine learning, especially LSTM networks, offers a more effective approach to spam detection. This study develops an advanced filtering leveraging a large SMS dataset to improve accuracy. Now, the existing system will set by the hash rate.
I am Ashit. Uh, in existing system, there are two algorithms we use: SVM and CNN. Existing in SVM, the process begins with feature extraction, where SMS messages are pre-processed and converted into numerical representation using methods like TF-IDF. TF-IDF stands for Term Frequency Inverse Document Frequency. And in CNN, we tokenizes text and applies layers to detect spam patterns that detect important features or patterns in the message. To classify messages into spam or AM after pooling and fully connected layers. And in proposed system, we use TF-IDF, LSTM algorithms. TF-IDF stands for Term Frequency Inverse Document Frequency, which helps capture the importance of each word in the message based on its frequency. And in LSTM is a type of neural network that is good at understanding the sequence and context of words, helping the system recognizes patterns in messages even if they contain subtle variations used by the spammers. Once LSTM process these vectors, recognizing sequence patterns and context, which are being classified using naive Bayes, which assigns a probability to determine if the message is original or not. And next, system modules will be explained by Bharat Kumar.
Good afternoon, sir. Afternoon, all. The first system module is data collection. We have collected different data sets from GitHub and Google Scholar and many research papers. We collected many researches, many measurements from different domains, and we perform this research. We develop this model. In data collection, we collect the data from different sources and we separate the data. Next module is data augmentation. In this module we remove the duplicate data and we separate English language and different languages separately using different methods. We remove spaces and restore in this method. Next module is text process. It reduces the noise and removes the special characters and removes unnecessary spaces and punctuations from this. It converts all the cases into lowercase and expands the construction like don't to do not, isn't to is not. And the next method is tokenization. It converts words, letters in separate letters into words and sentences, so that it can be easily understood by the national language process. Next method is LSTM model. We apply this model. In this model, we take the 61% of the data and which is used as for processing, and the remaining 39% is used for testing. We train the model so that we can separate the spam messages and normal ham messages, which is normal, which are not spam. And after training the model, we deploy the model in the real world environment to check the probability of success and failure. Sorry. These are the after executing. These are the log pages and home pages, registration page and input, and this is the output. We enter the input in this input page, and after entering, we get the output. If it is spam, it will show like this left image, and if it's like it is not spam, it gives output as right image. In future we want to develop this model so that we can detect the spam in different languages also. Even if the languages are mixed, we would like to detect them if it is spam or not spam. The conclusion of this paper is that we were able to detect whether a given message is spam message or not a spam message. We used a different LSTM model to detect the spam messages. And currently, we are struggling with there are so many spams that are struggling. There's so many spam messages that we get day by day. It will be hard to separate them. So we have to. Thank you. Thank you, sir.
Thank you, Mr. Bharat. What type of features you are extracted from the data sets?
We had different messages, which is different sentences and different messages we have taken from spam messages, some mass spam messages, and some normal messages. So we have found the pattern of spam messages and we taught the machine learning model to identify the spam messages.
Okay, fine. At the same time, you are using NLP, right? Natural Language Processing Toolkit, NLP.
Yes, sir.
So here you apply tokenization. So here, what type of tokenization mechanism had you used? Okay, you mentioned, right? Tokenization is there.
Tokenization.
Okay, so okay, fine, man. Thank you.
Yes, Bharat. Yes, Bharat. Hello.
No.
Bharat, what type of algorithm you are using? You have mentioned there CNN as well as RNN. Which one algorithm you are using to find out the accuracy?
That is CNN is used in a existing system, ma'am. In this, we are using
Okay.
LSTM.
Okay. No, in slide somewhere you mentioned that to design, we are using RNN algorithm. You mentioned this, so I'm asking like, are you using this RNN algorithm to find out the accuracy?
We are using RNN design, ma'am, to process the sequential data, and we can in future also we can capture, improve the data, and get the increase the efficiency of this.
Okay. Okay. Thank you, ma'am. Next.
Thank you, team, for your insightful presentation.
And our next team is CH Divya from Guru Nanak Institutions of Technical Campus. Please proceed, Divya. You have time limit of 6 minutes for your presentation.
Yes, good afternoon, everyone. My name is Divya, and with me, I'm having my team, the Sundar and Saumit Reddy, and under the guidance of Mr. V. Devashekhar sir, Associate Professor of Guru Nanak Institutions, he's working under Computer Science Department. Our project title is Detection of Social Anxiety of High School Students Using Machine Learning. We are here to present our project. Here, the overview of our presentation. We will walk you through the abstract, objective, existing and proposed system, architecture and its modules, and conclude with the future enhancements. Here comes the abstract. Social anxiety is a common issue among teenagers that affects their well-being, school performance, and relationships. We conducted a study at a school in Tanjavur using a 17-question spin survey. Using random forest algorithm, a machine learning algorithm, we analyzed the data to detect and predict the level of social anxiety in students. We also used future selection to find which symptoms or behaviors are most important for detection. And here comes the objective of our project. The main goal of our project is to understand how common social them. Here, we aim to predict anxiety levels using machine learning, and we measure how severe the anxiety is and identify what causes the high anxiety and create a model that helps in early detection. Here comes the introduction. Social anxiety is also commonly called as social anxiety disorder, which causes the fear in social situations. It affects students' emotional health, friendships, and school life. If ignored, it can lead to serious avoidance behavior too. So, our research helps identify affected students early so that proper guidance or counseling can be given. In the existing system, existing method, clustering algorithms are used, which group similar data points together. However, these are unsupervised and don't work well when we want clear prediction or diagnosis. They help in exploring patterns but lack accuracy in classification tasks. So here we propose using the random forest algorithm. It is an ensemble learning method that combines many decision trees. Each tree gives a result and the final prediction is a majority of all. This method is more accurate and avoids overfitting and handles real world data better. And here comes the system architecture of our project. This is our system architecture. Here we begin with the data collection, then we pre-process it and standardize the features and split the data set into training and testing parts. Here we train the model using random forest and finally evaluate the results. It is smooth and structured pipeline to ensure accuracy and the performance. And here are the system modules. Here are the enlisted down. And here in the first part, data collection, we collected data using 17-item questionnaire that asks about fear, avoidance, and discomfort, and many related to. And here, after collecting the data and handled missing values and converted it into mission readable form. And after that, feature selection. We choose the most relevant features from the dataset to make the model faster and more accurate. After selecting the features, we train a model. We train the random forest model using the selected features to learn patterns related to the social anxiety. And after that, we have evaluated our model. We tested the model using accuracy, precision, and F1 score to check its performance. And finally, prediction and the interpretation. Finally, the model predicts the anxiety level of new students and helps identify those who may need support. And here are the execution screenshots of our project. And here shows our login page where we, to get access, here we have to enter the admin name and password. After that, we have to log in. And here comes the next input data page. And here we need to enter the data of gender or are you a student and all those details. And after that, we'll be getting result page whether the student is having anxiety or not. And here in this case, here they are having anxiety. Here comes the last slide, future enhancement. In the future, we plan to use more advanced algorithms like deep learning. It includes more student information. It can include more student information like behavior or demographics. And we can also add real-time monitoring through mobile apps. So to conclude, our project uses random forest to detect social anxiety in high school students based on spin survey responses. The model can help schools take early action and support students emotionally. This project shows how machine learning can play a role in promoting mental health awareness in education. Thank you.
Divya,
Sir.
somewhere else you mentioned you are using clustering also, right? For your project.
Yes, sir.
But then you are not mentioned clearly about what type of clustering algorithm you are using.
Sir, actually, in the existing system, they have used clustering, sir. But right now, we are using random forestry. We are proposing random forestry, sir.
Random forest algorithm only you are using, right?
Yes, sir.
So in your presentation, nowhere else mentioned about the statistics about precision recall, all those things.
Yes, sir.
You got the results, right?
Yes, sir.
And that is the one thing. And you need to mention all those things, whatever the results you received by calculating the precision value, F1 score, all those things. And you mentioned some kind of prediction also you are doing, right?
Yes, sir.
For prediction, what kind of mechanism had you used?
Sir, mechanism in the sense like we after we train our model and after training on the input that we have given on based on our data set, it classifies the input data, sir. So after that, it predicts whether the student is having social anxiety or not.
Okay, okay. Right, ma'am. Thank you.
Yes, Divya.
Yes, ma'am.
Why dimensionality reduction is necessary? Because you have mentioned in your PPT, right?
Ma'am?
You're saying about like you're calculating F1 score, precision, recaller.
Yes, ma'am.
Where you mentioned those all the features metrics.
Yes, ma'am. That is what sir said that I have to mention and I didn't mention them in the PPT.
In PPT you mentioned dimensionality reduction.
Yes, ma'am.
Why dimensionality reduction is necessary?
Ma'am, because it uh, because it reduces many features like which causes overfitting and also which makes the model to slow so that we use dimension.
Okay.
Thank you.
Thank you, Divya. Now let's proceed with the next.
Our next team is Latika from Guru Nanak Institutions of Technical Campus. Please proceed your presentation.
Good afternoon, everyone. I am Latika with my teammates Nikita and Ajay. Today, I will be presenting our paper titled Sensor Based Head Injury Detection Using Machine Learning. This is like blends health, safety, and technology. And this was under the guidance of MS CH Nagamani ma'am, as assistant professor. And this project is about detecting head injury using sensors and machine learning. And we tested like different algorithms, XGBoost, random forest, and logistic regression. And from all this, we found that logistic regression worked best. So we also explored the best spots on the head to place sensors so that we use a fewer of them and still we get the more accurate result. And our system is designed to be fast, simple, and helpful in real life situations like sports and industry safety. And the main objective is to accurately detect head injury using piezoelectric sensors and machine learning. And the idea is like to quickly spot injury risk from impact data so that we can respond faster, whether it's on the field, at work, or during an accident. And ultimately, we want to help prevent injuries and improve the safety. This is the main goal. An introduction. Head injury can be very dangerous and early detection is crucial. Our model uses smart sensors and machine learning to detect the impacts, and the sensor collect the data like force, speed, and hit, and the machine learning algorithms decides whether an injury is likely. And we also optimized where to place the sensors for better performance. And from the previous like when we surveyed few papers from the previous one, we found that like those papers or those project only find the impact, whether the ball hit the head or not, only find the impact but it does not find the injury. So from that we took the main thing that to find the whether they face any injury or not. And in the existing system, it uses XGBoost algorithm, and it's powerful and accurate but needs a lot of data and time to train, as it is based on the head. So the decision should be taken fast. So the XGBoost is it does not work on the decision making properly. It also needs high-end hardware and it is hard to interpret. So while it works, it's not ideal for simple real-time applications. So it's not better to use XGBoots. So from that, we found that logistic regression works better on this, as the proposed system uses logistic regression, and it is a machine learning algorithm. From that, it finds only like a two outputs, whether yes or no. So in this, it finds whether injury or no injury, and it predicts whether an injury happened or not based on the impact data. And it's fast, easy to understand, and works well even with a small data set, and making it perfect for real time use. So this is easier to understand in, and it also works well for the small data set. So for this model, it's better to use the logistic regression. Now the system architecture will be explained by the Nikita. Over to you, Nikita.
Good afternoon, everyone. Here is how our system works. First, sensors collects data, then we clean and process it. We pick the most important features and split the data into the futures and training and testing data and train the model. Finally, we test it and deploy it. Here are the some modules. First is the data collection. Sensors detect impact on it, and we are giving to data cleaning to improve accuracy. And next is future selection. Here we pick up the only important details like force, speed, location for the training. And next is the splitting of the data. Here the data is divided into two parts: training the data and testing the data. In training the data, it teaches the model, and in testing the data, it checks how well it works. In training the model, we uses the logistic regression to learn from training data is predicted injury or no injury. In the testing the model uses the testing data to see how the model is accurate. And next one is evaluating the data. It's evaluate data and gives the output. Next comes to the system requirements. We kept our system lightweight. It runs on basic hardware, just as i3 processor with 2 GB RAM, and uses Python in the Spider IDE on Windows. This means it's accessible and does not need expensive tools. And next are the here are the some glimpse of our project, our system, our system. It is a login page. Next.
Sorry, team, to interrupt. We only have 2 minutes to proceed.
Next page. Here, here are the some input values we have given here. By these input values, it detects the whether the result is low risk or high risk. Next, future enhancement. We plan to improve the system futures by adding more sensors, using advanced algorithms, and enabling it learning from new data automatically. We also aim to make it faster and more scalable so it can handle large environment data. Next conclusion. Uh, Here, our model uses logistic regression with sensor data to detect head injuries quickly and accurately. It's low cost, easy to implement, and uses in sports, industries, and military settings. It proves that simple solutions can also be powerful. Thank you.
Ritika,
Yes, sir.
you are using a sensor-based technology, right? Can you name it? What type of sensor are you using?
It's a physioelectronic sensor, sir.
Visual center. Okay. And what is the training data set size and the testing data set size which you divided?
Yes, sir. Training data set is divided into 80% and testing is divided into 20%.
And last question here: why you are saying logistic regression is good? It
Yes,
will
sir.
improve
For
accuracy.
Yes, sir. For this, we can uses only one thing: whether the person is injured or not injured. So it is the best to use the logistic regression.
Then what about XBoost? That is advanced, na?
Yes, but according to the data, logistic regression is better than the XGBoost. XGBoost can be complex and more overfitting. So we
Oh,
are using the logistic regression.
it's okay, ma. Fine. Thank you.
Thank you, sir.
Yes, Likita.
Yes, ma'am.
What type of input you are giving? You are saying that head injury or not. What type of input you are entering there?
Yes, ma'am. We are entering age. Uh, Age, whether the person is skull is fractured or is conscious or not. Open skull is fractured, or whether the person is occurred vomiting after injury, or whether the person needs a clinical important brain injury. We are using these inputs, ma'am.
Okay. One more question. XGBoost advantages like to find out the mistakes of the previous one, correct?
Yes,
So
ma'am.
why you are specifically mentioning only logistic regression than XGBoost?
Yes, ma'am. Logistic regression can be used for the low data, and it can be gives an correct accuracy value whether the person is injured or not injured.
Okay.
Mm.
Thank you, team Latika, for your presentation.
And a small reminder, we have break at 1:10. After 10 minutes, I'll break. Sorry, but the break is at 1:20. We have 20 minutes break. And our next team is Musa Harshita. Please proceed with your presentation. Team Musa Harshita, please proceed and on your video. You have shared 6 minutes to present your presentation.
Good afternoon to the respected sir and ma'am. My name is Harshita. I am here to present our project titled Enhancing Cardiovascular Disease Detection Using Machine Learning and Optimal Feature Selection Technique. So the overview of the presentation. Here comes to the abstract. Cardiovascular disease are one of the major causes of the death worldwide nowadays. So our project uses machine learning to predict cardiovascular disease more accurately. So here we used an optimal feature selection technique, which is called as FCBF, that is fast correlated based filter. So it is used to pick the most important relevant features like health indicators. So then we applied the random forest algorithm, so where it has high accuracy and handling the complex data well. So here comes to the objective. The main objective of this project is to develop a machine learning model. So where we will use it to detect the cardiovascular disease, and we also want to identify which health features are most responsible for the disease. And here comes to the introduction. Cardiovascular disease is a big health problem worldwide. So it is often caused by the issues like high blood pressure, lack of exercise, smoking, and genetics. So here comes to the existing system. In older systems, we used one method, that is PCA, that is principal component analysis. So where it reduces the number of features by turning them into a new components. So but PCA can be complex and important data might get lost. So while it helps to reduce the data, so it's not always the best for medical prediction. So we are using the random forest, that is our proposed algorithm. So where which is used to build the many decision trees and combine their results. So this helps the model to be more accurate and less. So also we used the FCBF, as I told in the introduction, that is fast correlated based filter, where it is used to take the relevant features, that is most important health indicators, and use it to remove the unnecessary information. And here comes to the system architecture, and we have here the data, the way we should collect the data, and the data is split into the training data set and testing data set. And next come to the algorithm. So the model should be trained and the prediction we should evaluate it. The system models. First we should data collection. So where we should gather the 918 records with 14 important health features. So next we imported the libraries like pandas, NumPy and TensorFlow. And next we splitted the data, that is training to the 80% and testing to the 20%. And finally we train the model using 11 selected features. So it predicts whether the person has heart disease with good accuracy or not. And here comes to the login page. And next the home page, and we took the most important relevant features like age, chest pain type, gender, cholesterol, all these. And next come to the future enhancement. In the future, we can plan to test more feature selection methods and improve the model accuracy. So we want to make the system more flexible and usable in hospitals and clinics. And here comes to the conclusion. So to conclude, our machine learning based model can help to detect cardiovascular disease early using smart feature selection and accurate algorithms like random forest. So it is a step forward in using technology to improve healthcare and save lives. Thank you. Yes, sir.
Yes, Sita, you are using FCBF, right?
Yes, sir.
At the same time, you are using our random forest as well.
Yes, sir.
Both. Then why you are achieving only less accuracy, that is less than 78 something?
So 85% accuracy.
Yes. Why you are getting less accuracy? Even though you are using random forest and FCBF.
Sir, according to the data set.
From where you downloaded data set?
Sir,
had you collected any real-time data or were collected from any repository?
Sir, repository. Cargill website, sir.
Cargill. Okay, fine.
Ma, what's the size of your data collected?
Sir, ma'am, we took the 918 features, ma'am. So that we selected the most 11 features because we are using the FCBF now. So most important features it should be selected. So removing the unnecessary ones.
Okay.
Thank you, team Harshita, for your
Okay, ma'am. Thank you.
presentation.
Our next team is Yashasvi from Guru Nanak Institution's Technical Campus. Please begin your presentation.
Good afternoon, everyone. Good afternoon, everyone. This is Yashasvi. Today, I am here to present our major project titled
Your
Machine
presentation
Learning.
is Shashvi. Your presentation is not visible, ma. Can you check it once?
Sir, 1 minute. Sir, now it is visible, sir.
No, ma. It is not visible. Can you share entire screen and then can present.
Yes. Now it is visible, sir.
Yes, ma'am. Yes, you can start.
Good afternoon, sir. My name is Yashasvi, and my teammates are Vignan and Abhay Narsimha. I am here to present our project titled Machine Learning Based Heart Disease Prediction. Sir, is it audible?
Yes, ma. Yes, you can carry on.
And this is the overview. Coming to the abstract, heart disease is one of the leading cause of deaths across the world. To overcome these challenges, we developed a machine learning based prediction system that can detect the heart disease in earlier stage and quickly, and it will give the accurate results. This idea is to use patient data and use the intelligent uh, algorithms and make prediction that can assist healthcare professional and even patients directly. Coming to the objective of this project, it is to create the model that can analyze medical data and predict the risk of heart disease. In this, we have used three powerful feature selection techniques like ANOVA, mutual information, and chi-square. This is used to find out which, uh, like patient details like age, blood group, blood pressure, etc. And coming to this introduction, in this project, we have we used existing system as a XGBoost algorithm and proposed as a AdaBoost algorithm. Our existing system is XGBoost algorithm, which stands for Extreme Gradient Boosting Algorithm. It is a powerful machine learning technique that works by building a multiple decision trees where each tree corrects the mistakes of the previous one and give the high accuracy compared to the previous one. And our proposed system is AdaBoost system. It works by starting with a simple model, then identifying the given more weight and misclassified data. It keeps improving by focusing on the difficult cases. But at last, it combines all the weak modules into strong classifier. And coming to the system architecture, firstly we start and then we load the data, and next is the pre-processed data. In pre-processed data, it cleans and handle the missing values. After that, the data will be is splitted into training data and the testing data. After that, we will be training the module by using different machine learning algorithms. After that, we'll be calculating the accuracy, how much accuracy we got, and we'll be giving the output. And we have five system modules. First one is data collection. In data collection, we gather the patient data from both public data set and private sources, including health indicators like blood pressure. After that, data pre-processing. In data pre-processing, we'll be cleaning the data. Like if we find any missing values, we'll be removing and we'll be balancing the data. After that, feature extraction. By using ANOVA and mutual information, we'll identify the most important feature to use the prediction. After that, model application. We train. After getting the result, we'll be training that, and after this, accuracy. Accuracy after
After doing all these above we'll be doing accuracy.
You only have 2 minutes to proceed with your presentation.
Coming to the execution screenshot, this is the home page of our hard disk prediction, and this is the login page. In this, we have username and password, and after this, we have input field. In this, we will be inputting our symptoms, age, like age, gender, and blood pressure, like this. After this is the final result. In this, we got high chance of heart attack. Future enhancement. Why we choose this? Why we did this after? Because it gives more accuracy, and it will help patients to get. Coming to the conclusion, it is the best machine learning model which predicts which helps doctors and patients uh, to to predict heart disease quickly and get accurate result. Thank you, sir.
Yashasvi,
Sir,
you mentioned that you are using so many parameters like F1 score, all those things, accuracy,
yes,
precision. So among
yes,
those, which parameter will efficiently tells that your work is more accurate?
sir will be taking attributes like whether he's uh, according to his health condition, sir.
No. I'm asking which parameter will more justiciable for your work, either accuracy or precision or recall.
Accuracy, sir.
Accuracy. Okay, then have you collected data, right? Data sets, right? Regarding heart
Yes,
related. So what kind of data you gathered? Either image data or any kind of text data or multimodal data?
text data, sir.
Text data. With text data, how will identify heart disease prediction?
Sir will be giving inputs in that model, no, sir.
Okay, ma, thanks.
Yashasvi,
Ma'am.
by considering text data, can we predict this heart disease? At least images are required, right?
Yes, ma'am.
MRI images are required.
Yes, ma'am.
ECG, correct? Images are required, right? The data set.
Yes, ma'am.
What is the function of that ANOVA?
Analysis of variance.
Okay, where you are using that ANOVA in your project?
Ma'am, we'll be selecting which feature it is used for, that only, ma'am, for selecting the features.
Okay, one more thing, like in title you mentioned that heart disease classification, but you are saying here prediction. Please look into that. Okay,
Okay.
thank you.
Thank you.
And now it's time for break. And I request everyone to be sharp at 1:50. Gayatri, you can start the session. Yes, ma'am. Let's continue the session. Our next team is Pranav Bhatt from Jyoti Institute of Technology. Please proceed with your presentation.
Good afternoon to one and all present here. I'm Siddharth, and today me and my team are going to present about our paper, AI-based agent for medical healthcare support. Pranav, can you present the slides? Okay, now coming to our problem statement. As AI is growing, and even as AI is growing, the healthcare system has a lot of challenges, and AI, we are trying to integrate AI into the healthcare system, and basically where we see the problems are when there's a bit of miscommunication when the doctor prescribes the diagnosis, and this diagnosis is misinterpreted by the receptionist or the medical store receptionist. So in our paper, we are trying to integrate agents into our software, and this agents is used to automate stuff like booking system, and also the medical medicines dispenser. So we have also provided a chatbot to our medical healthcare support by which does a image analysis, and it gives out the lab reports, and it points out any faults in the lab reports. And also we can also it can also predict the medicines it dispenses by asking the symptoms. Next slide. So in our AI driven assistant can read the documents, and it can read the lab reports, and also tell what the mistakes are in it, and if there's any deficiency present in our lab reports, and it can also do a real time booking appointments, and medicines can also be dispensed by our agent. And we have built this by using a framework called Google Agent Development Kit, and which is a recently released framework which is used to make an agentic ecosystem. Now, Pranav, can you explain the methodology?
We have used React plus TypeScript for the modern UI and type safety. We have also used for backend. We have used Fast API for high performance REST API calls. So we have used Firebase for the database integration, and both database and authentication part. So the agentic framework is mainly handled by the Google ADK with a thinking model named like Gemini 2.5 Flash, which is a multi-model LM. So this is the agent workflow. We have made the main agent as medical agent. So that's the orchestrator agent, which will handle and call other agents to make the response for the given input by the patient or the doctor. So we have successfully implemented these core modules. So authentication, we have successfully created authentication for both doctors and patients separately for proper session handling. And doctors and patient can easily track appointment booking. A patient can book appointments through our chatbot directly through natural language. So whatever the user asks the chatbot, it will tell the user properly only the medical stuff, and it will also give some suggestions about the prescriptions, and also basically the agent just the main agent will just route to the other agents. This is the UI and the website we have built. There is a patient dashboard and a doctor's dashboard, and there's a calendar of events for the doctor to track appointments. Okay, Anush, can you continue?
Okay. So for the conclusion, our system uses a model age architecture which is built by using Gemini AI and also ADK, making it flexible as well as scalable. So and also it enables real-time doctor Q&A, appointment scheduling, medical services, and generation all in one platform only. So also we have achieved 90% accuracy, 92% overall positive satisfaction, providing effective and reliability. And for the future enhancements, we are planning to launch Android and iOS app, making it accessible to everyone. And also we are trying to implement a speech API, making it hands-free for the patients. And also we're planning to implement multilingual support, languages like Spanish, Hindi, and other languages to reach non-English speakers. That's all.
Yeah, Pranav.
Yes, sir.
Yeah, had you implemented a chatbot like system, right?
Yes.
So what kind of input it can be acceptable?
Natural language input. It can take natural language input. It can take PDFs, images like X-ray, PDFs like lab reports, images like X-ray, MRI, CT scan.
It can take by means of text as well as images, right?
Yes.
Okay, then whenever we are considering that image, how it will be pre-processed the image, and how it will be processed, and how it will generate the results according to client.
Under the hood, we have used the multi-model LLM Gemini 2.0 Flash, which is capable of doing various works, and as it is a reasoning model, also it can think and provide responses accordingly.
Okay, fine, man. Thank you. Next batch.
Next batch, ma.
Thank you, team. Next team is Samata Sri Chaturved from Satyabama Institute of Science and Technology. Please proceed with your presentation.
Good afternoon, ma'am. Good afternoon, sir. This is Samata Sri Chaturvedi. I am really very honored to present my research, which is titled An Integrated Privacy Preservation and Blockchain Model for Secure Data Transmission in Medical Applications. I am a research scholar from Satyabama Institute of Science and Technology. This is my So this is an introduction. As digital healthcare is growing through electronic health records, telemedicines, and smart medical devices, securing sensitive patient data has become more crucial. So the traditional security systems has often very reliant on encryption and different types of centralized controls, which are increasingly inadequate. So my work, it addresses this gap with a unified model, which is the combination of blockchain technology, homomorphic encryption, and zero knowledge proofs, which ensures data privacy, integrity, and secure access. And the main aim is to propose a framework which ensures both the privacy and the security by using this hybrid model. With the hospitals which are evolving and which are handling massive volumes of digital health data, and different types of threats like unauthorized access, data tampering, and man-in-the-middle attacks are becoming more frequent. And moreover, conventional systems, it doesn't allow computations on encrypted data, which limits the collaborations and different types of analytics. So real-time healthcare systems are on demand, which has to be latency and it should be very scalable and has to be secured. So my proposed solution, so the main objective for this research is it will have a secure and privacy transmission framework, and we are going to integrate the blockchain to avoid the tampering, and we can have confidentiality by using the homomorphic encryption. And this is the main methodology of my research, where it is having 4 steps. The step 1 is called as the data collection, where we are going to collect the data from multiple hospitals whose diagnosis of different patients and generate the electronic health records. Next, we will have the data encryption as the second step. The patient information is protected using the homomorphic encryption technique, and where here in the encryption phase, each transaction is digitally signed to secure the authenticity of the patient. And the third step is the blockchain storage. Here, the encrypted data is recorded on the blockchain. By using smart contracts, it will manage the access only by allowing the authorized users, those who can retrieve the data, so that we can have the authenticity. Next, the fourth step is the access and the computation. So here we are going to use zero knowledge proofs. These are these will validate the user identity without exposing the patient's information. And this is the proposed solution, where the integration where it integrates the blockchain technology with different the advanced cryptographic mechanisms which secures
Yes, Samantha.
Sir.
Samantha?
Sir.
You are using encryption, right?
Yes, sir.
What kind of encryption you are using, and what is the key size?
Sir, here I am using the homomorphic encryption, sir.
Okay.
No, I don't know the size, but this homomorphic encryption
key
which
and decryption key size.
May correct. I didn't have the correct idea, sir.
Okay. And then you are using a blockchain model for, right? Blockchain
yes,
model.
Sir. Blockchain model.
That means you are implementing a blockchain-based network type thing, or just you are developing
for securing the data, previously we had used different types of like AES techniques, but here by using blockchain, we are used to store the patient's data will not be revealed. By providing this homomorphic encryption, it will not be revealed, and zero knowledge proofs, these will be enabled, which means it will not give any access to the other third party members. So by using these two techniques, we can have the secured data.
Okay, ma. Thank you.
Okay, sir. Thank you.
We'll stop right. Next batch.
Next batch, ma. Gayatri.
Thank you so much. Thank you for the presentation, and now we are like to end the session very fast. So everybody is requested to complete their presentation within 3 minutes. And for the next presentation, I would like to invite Pratham and group.
Hello, am I audible?
Yeah.
Okay. Okay, so good afternoon, everyone. My name is Pratham Tanpure, and I'm truly honored to be presenting our paper today, titled "An ALM-Driven Framework for Finance Video Question Answering" here at National Conference on Futuristic Technology. This work was co-authored by my fellow students Vishal Antiford, Anushka Vaksavre, and Devashila, under the guidance of our mentor Ashok Kumar Kalal. We represent Anantrao Power College of Engineering and Research. Today, I'll be taking you through a journey of how AI, especially large language models, can turn passive financial video into dynamic interactive tools. Here's a quick overview of what we'll be sharing today. We'll begin the motivation and introduction behind our project, define the core problems, then walk you through our proposed solution and objective. We'll also dive into related research, system design, sample results, and finally explore future possibilities and conclude with key takeaways. We live in, let's start with the introduction. We live in a time where video is a new textbook. Platforms like YouTube are full of financial tutorials, market explainers, and budget background. But here's a challenge. Let's say you're watching a 30 minutes video on stock trading. and all you want to know is what's the difference between fundamental and technical analysis. You scrub through the timeline, rewind and rewatch, and still it's frustrating. This inefficiency inspired the emergence of a new research trend, video question answering, a field where AI enables user to interact with videos like they would with the human expert. So taking with the next slide, problem statement. Traditional video search is linear. You have to passively consume content until you find what you need. Now imagine being able to simply ask, what are the key tax saving strategies mentioned in this video, and instantly get the answer without watching the whole video. This is especially valuable in finance, a domain rich in jargon, complex reasoning, and time sensitive information. We saw a clear need for intelligent systems that allow users to query video content directly in natural language and receive contextually accurate answers. Uh, Taking to the next slide, solution. Our solution uses an end-to-end pipeline. We start with speech to text conversion using OpenAI Whisper. Then we extract keywords, generate a summary, and finally use GPT-4 to answer user queries based on the transcript. We also fine-tune prompts so that AI understands financial jargon and context. Our objective is to build an intelligent system that enhances how people learn from finance video, making the process faster, smarter, and more personalized. So, going through the literature survey, now let's look at what the literature says. Several peoples have shaped this field. Zhang et al. Provided a foundational survey of video question answering using AI. Gupta and Roy focused on educational video analysis. Other researchers explored NLP, video captioning, and multimodal learning. One thing stood out: a very few studied address financial content. This gap motivated us to design a domain-specific solution for finance, where precision matters the most. Talking about in our analysis, we found most of the system focuses on only one task, like transcription or captioning. But our framework,
Patan, sorry to disturb you.
yes, sir.
Please continue the methodology and what are the work you have done and what parametrics you have considered to get the accuracy. This much only explanation is required. Okay, na?
Okay.
Okay. Thank you.
Pratham?
Yes, sir.
What type of inputs can your model is able to take?
Sorry?
What type of inputs? It only audio or image,
Yes,
text,
sir.
or
Audio,
multi-model image? It can able to take?
multimodal. It is
Multi-model.
multimodal. Yes, sir.
Okay, then how that image will be processed at the backend side?
Okay, so
Whenever it is
basically
going to take
we are using
as LLM
OpenAI.
model.
Okay, so basically we are using OpenAI Whisper for transcribing and
Mhm.
GPT-4 for answering the questions.
Mhm.
The backend runs on Python with libraries like Python Torch, TensorFlow, and Flask. We have
Okay.
used tools like VS Code, Python, PyCharm for development.
Have you ever worked with Keros?
No, sir, but
No.
we'll make sure.
Okay, fine, man. Thank you.
Okay,
Next
thank you, sir.
batch.
Thank you, Team Pratham, for your presentation. And our next team is Shraddha Gateda from Keshav Memorial Institute of Technology.
Madam, if he is not ready, can we go with some other guy?
Okay, sir. Gayatri?
Okay, our next team is Ria Tony from Amal Jyoti College of Engineering.
Gayatri, if they are not ready, please announce the next batch.
Ria Tony, please respond, team. You can start your presentation, Ria Tony team. Okay, our next team is Raja Sri from Maharashtra Institute of Technology.
Rajashri team, please proceed with your presentation.
Yes. Good afternoon, everyone. Myself, Rajashri Sunge. I'm studying in second year of MTech. I'm presenting this paper under the guidance of Dr. S.J. Nandedkar, ma'am. My paper is survey paper, a survey on smart farm protection systems. The main purpose of this paper is addressing wildlife intrusion and giving accurate, cost-effective, practical solution to the farmers. Because of rapid urbanization and the continued degradation of natural habitats, animals are increasingly entering human spaces in search of food. This has led to significant crop damage, financial distress for farmers, and rising human-animal conflict. Traditional methods like physical fencing, manual patrolling are not only labor intensive but often ineffective across large areas. Fortunately, the digital transformation in agriculture is opening now new avenues to ensure a focused and
Rajashri, can you focus on your implementation thing? This is not required. Can you focus on implementation thing and some kind of result section?
Okay, sir. Actually, this is a survey paper, sir. I have different technologies are used in farm protection systems. The comparative analysis of different technologies is done here, sir. There are different technologies used, sensor-based systems, as you can see on the screen. RFID tagging, circuit-based triggers, WSN, IoT, etc. Then next is geofencing and GPS monitoring.
How many papers you did, sir? You consider for survey?
10 papers, sir.
10 papers only.
Yes, sir. This is the comparative analysis.
Then you are not ever mentioned about some kind of parameters which you consider here. You mentioned some kind of art of survey comparison, right?
Yes, sir. Actually, the main purpose is for wildlife animal intrusion.
That only my intrusion detail is there some system you are implementing, right?
Yes, sir. Scalability. The solution, the prototype or the system should be scalable in large areas, and it should be sustainable in extreme weather conditions, extreme rain or in extreme heat, in
Fine.
extreme darkness.
Thank you.
Okay, sir.
Thank you.
Next batch.
Thank you, Rajashri and team, for your presentation.
Our next team is from Ria Tony from Amal Jyoti College of Engineering. Gayatri, if they are not ready, please announce the next batch.
Yes, ma'am. Our next team is Anup Yadav from Guru Nanak Institutions of Technical Campus.
Tilu.
Anup, you can continue.
Hello.
Am I audible?
Yeah.
Good afternoon, everyone. My name is Navin. My teammates Anu and Chandana. Today, my project name is Development of Smart Machine Classification and Predication Artificial Intelligence. Abstract image classification and the predication has been essential take various fields, including healthcare and security and automation. The advancement is artificial intelligence, have established the development of smart machine capable of classification image with high accuracy. This smart machine aims to provide a secure, user-friendly interface and real-time classification capability. Enhancement it's applicable across different domains. Objective accurate image classification. Develop a machine learning module that can accurately classify image into three different categories, such as objective, scenes, or
Navin, can you go for implementation part, man?
okay, sir.
Implementation part. Okay.
Good afternoon, everyone. This is Anup. I think my friend might have some internet issues. I'll continue from here. These are the existing system that we have gone through our project. The drawbacks of our existing system of our projects are data quality and the quantity requirements, and the model complexity and interpretability. The proposed system of our project.
No, implementation. Going to go for outcomes.
Outcomes, okay.
Yeah, outcomes. Next.
System
No, outcomes, outputs.
Yeah, these are the execution screenshots. This is the main homepage of our app that we have developed. This is the homepage that shows the analyze and the scanner page.
So here, wait, Mr. Anup, what type of parameters you are using?
I didn't got you, sir.
Here you are mentioning, right, smart. You are developing some kind of image classification model,
yes,
right?
Sir. Image classification and
here, what type of parameters you are using to classify whenever image is going to be classified? So what type of
we are
parameters?
using the AI tools to classify the image that we scan in our camera, sir.
That only okay, man. What type of parameters you are using?
No, that is the
Like how the image accuracy will be there.
Yes, sir.
Precision, recall, like that.
Initially, we train the model, sir. Initially, we train the model with the sample images so that we can scan the images so that the output will be generated by the scanner, sir. These are
that
the
means you
output
are totally depending on tool, right?
Yes, sir. AI tool.
Yes, fine,
We should
man.
initially train the tool, sir.
We'll go with the next.
Okay, sir. Thank you.
Yes, my next match. Our next team is Alta Sakshita from Guru Nanak Institutions of Technical Campus. Team Akshita directly go with the methodology and execution.
Good afternoon, everyone. I'm Ananya Reddy, and here is my mate Akshita. Today's topic for our conference is efficient single infrared image super resolution. Before diving directly into the topic, let's understand what infrared imaging technology is. Basically, it is used to measure the temperature of an object. I mean, the hotter the object is, the more infrared radiation it emits. From abstract, we have infrared images basically has major benefits. One such is it allows us to see things that are not visible by human naked eye. Our project focuses on enhancing the resolution of infrared images using computational techniques. So, our objective here is to develop a computationally efficient algorithm, a model that takes lower resolution infrared images and produces a high resolution version of the same image with improved clarity and detail. So basically, what is super resolution? Super resolution here in our project is the process of increasing the spatial resolution of an image, like adding the pixels in a smart way to enhance the detail. So here we introduce a deep learning based approach to enhance the resolution of an infrared image. For an
Ananya,
existing system, yes sir?
Ananya, what type of deep learning mechanism you are using?
So for an existing system, we already use here in our screen we can understand we already use for existing system a deep learning method called recurrent large kernel attention network, but due to the drawbacks we have in that we proposed a new model known as GAN technology, which my mate Akshita will you explain in detail.
Here comes to the proposed system. Our proposed system is GAN, which stands for Generative Adversarial Network. Are a class of deep learning models used to generate synthetic data that closely resembles real data. GAN involve the generator and discriminator. There are many applications of the GAN. Here are the advantages of the GAN. And coming to the system architecture, how our system works. Here is the object, lens, GAN, thermal image. Coming to the object in the diagram consisting of the plant as well as soil samples, IR waves, the infrared radiation emitted by the object that carries a temperature related information. Lens, the lens focus the incoming IR radiation onto a surface or area. GAN, this focuses on the IR signals or pass it to the GAN. Signal processor, the output from the GAN is then processed using a signal processor. Thermal image. These signals are used to generate a thermal image. And here are the snapshots, execution screenshots. Yes, sir.
So, what is the maximum resolution
Yes, sir.
which you obtained as an output?
Yes,
That is the maximum resolution. So, but
Infrared image.
you are giving us some image as input. So, what is the maximum resolution which you achieved?
So, for instance, if we take a 70 to 80 percentage of the images, I'm considering 10 to 15% of the validation. We generally got the images clarity range from 85%, ensuring there is no overlap in the content, sir.
Right. Thank you. Next batch.
Low resolution image to high.
Okay, ma. Thank you.
Sir. Thank
We'll
you.
go
Sir.
with the next batch.
Thank you, sir.
Thank you, team. Akshita, this was next.
Our next team is Amulya Reddy from Nanak Institutions of Technical Campus.
Gayatri, if they're not ready, please you can call next batch.
Our next team is Riya Tome from Amal Jyoti College of Engineering. Please proceed.
Good afternoon, everyone. I am Philomena Tom.
And I am
So along with Riya, we have submitted our research paper. Today's topic of
Can
our
you share your screen?
conference is
Can you share your screen? It
okay,
is not
sir.
visible.
Ria, please share your screen. So today's topic of a conference is a comparative study of traditional machine learning and deep learning approaches in predictive analysis. So let's move with the presentation.
Sorry to interrupt, but you have only 3 minutes. Just proceed with your methodology.
Okay.
You can go to that more results comparisons.
Oh, sorry.
Why? Because we don't have much time.
Ria, would you please take the introduction part?
No, not required. We can go for this is survey paper, right? So we can go with some kind of comparative study.
Okay, so our common health challenges are in today's fast-paced world. Managing health effectively can be a very hectic task. Many individuals struggle with their everyday issues such as forgetting medications, missing important documents, lack of structured health monitoring, difficulty in accessing emergency contacts. But while we saying these things, these are very simple. But when it comes to a real world scenario, this becomes a very crucial thing. So the methodology is MedMind makes managing our health simply with everything you need on top, such as medication reminders, which helps to never miss a dose with smart alerts, health tracking, appointments, emergency SOS. With MedMind, taking care of our health is easier than ever. So here we have added some case studies of a person who was struggling with chronic conditions. Before using Metmite, he faced the challenges such as missing dose of insulin and blood pressure medicine, no structured log of sugar or BP readings, missed two specialist appointments in 1 year, also family unaware during a my health emergency. So after using MedMind, he was able to overcome these old challenges before he faced. So next is the key features of our MedMind application. So it will continue by Ria.
What kind of inputs you are taking, ma? What kind of inputs you are considering here?
Inputs like reviews from other peoples, and also we have considered the advantages and disadvantages of already existing technologies.
Guide mark का solve नहीं किया था, लेकिन guide mark we are not adding.
Okay, what type of reminders you are sending?
Guide marks we are not adding.
What kind of reminders you are sending, ma?
Reminders like if they have missed their medicines, there is a icon to put a tick mark when they already have done their today's medicine. Like,
So okay, ma, fine. Thank you.
Okay.
Next
Then
batch.
can I?
Thank you, Team Ria. Now let's proceed with the next.
Our next team is Shraddha Gateda from Keshav Memorial Engineering College. Team Shraddha, please proceed.
Hello. Hello, mom. Hello.
Okay, then.
Mom, please, you can continue.
Team Shraddha, are you there? Please respond.
Hello. Hello.
Yeah.
Yes, ma'am. Ma'am, you can continue.
Actually, your camera is not visible. Are you able to see, ma'am?
Ma'am, screen is not visible.
Yeah, its camera is not getting on. Ma'am, 1 second. Shraddha is joining. My one more author is joining from another laptop. Camera is not getting on from this laptop. She's joining.
Okay.
Okay, then we'll give you 2 minutes. We'll move to the next team.
She's
Amulya Reddy from Guru Nanak Institutions of Technical
Yeah, she has got connected, ma'am.
Hello. Good afternoon, everyone.
Okay.
I'm Amulya, presenting our paper titled Advanced NLP Models for Technical University Information Chatbots, done along with my teammate Sai Ganesh under the guidance of A. Sunita ma'am. So coming to overview, this is the overview. Coming to abstract, so basically students often get confused because different sources.
Amulya Reddy, sorry to disturb you. Please proceed with proper this methodology.
Methodology. So here coming to the system architecture.
Yeah, explain system architecture. And what work you have done in your project, please explain that.
We have created a chat, coming to system architecture here. First step is the initial planning. So before building the chatbot, we decide what questions will it answer, what information do we need to provide, like that. And next is the JSON file creation and pre-processing. We should collect the data, common questions like or expected questions, and store them in a structured file called intents.json. So next, pre-process the data, clean the text, remove extra spaces, convert everything to lowercase, break sentences into words, and reduce words to their root form. This is called lemmatization. And next is a decision like continue or stop. After the initial setup, check that is the data is ready or not. And next, NLP model and building training. Feed it if the prepared data so it can learn how it will classify questions and pick the right answers. And next is the evaluation and prediction. Test how well the model works. Check its accuracy, like how many answers it gets right, and performance. Next is the deployment. Once it works well, deploy, like publish the chatbot live, usually on the university website, so students can interact with it in real time. And next is the feedback and improvement. Collect feedback from students, like are they satisfied with the chatbot answered correctly or not, like that.
Okay,
And coming
Amulya.
to
Amulya, why you specifically chosen the JSON file format rather than the CSV or ARFF or some other?
So I have chosen the JSON file because it is lightweight, easy to read and write. Like it is widely used for data exchange and integrates well with web applications.
XML also there, na? XML also lightweight only, right? XML file format.
So JSON file is simpler, less verbose, like faster to parse and easier to handle in modern programming languages.
No,
Like
the
compared
thing
to
is, whenever we need to do some kind of data manipulations in future, in JSON file format, we can able to do easy manner data manipulations in future after inserting the records, right? Right, Amulya?
Yes, thank you.
Yes, thank you. Next batch.
Our next team is Shraddha from Keshav Memorial Engineering College.
Hello. Hello. Yeah, it's audible, Shraddha. Please continue. Yeah, it's audible.
So, good afternoon, everyone. I am Shraddha Guptadar, studying Bachelor of Engineering in Computer Science Engineering from Keshav Memorial Engineering College.
Amma, can you
And
share
my
your
title.
presentation? It is not visible to us.
Just a minute. Now, sir. Hello.
Yes, visible, ma. Visible.
Okay, sir. Okay. So my title for the paper is Decision-Based Precision Farming using Wireless Sensor Network. And the co-authors of this paper are Dr. Patil Yogita Dattatreya, Department of CSE, KMIT Hyderabad, and Miss Pooja Kulkarni, Department of CSE, GNITS Hyderabad. Okay, let's see the abstract of the paper, which says agriculture played important role in the growth of Indian economy. Quality growth in agriculture achieved by use of new technologies. One such ever-growing area is precision farming, with the advancement in WSN technology. Routing techniques such as DCEM has minimal delay for non-critical data. PFWOCB provide transmission of energy of emergency data with maximum delay. PF-Actin also incur more delay. Decision-based precision farming in wireless sensor network, so DPF, support transmission of data without delay in critical events such as soil moisture or microclimate conditions exceeding beyond the set threshold. Minimize delay by cluster-based approach. So contents are listed here. Now let's see the introduction. A large population of India majorly depends on the growth of agriculture production. WSN support for precision farming using latest technologies for different soil types, temperature, and humidity. Various routing protocols are proposed to minimize energy consumption of the node during data transmission. These protocols fail to minimize delay. The proposed DPF support transmission of data without delay. Now let's see how the WSN supports precision farming. Precision farming is a farm management approach that uses information technology and data analysis to optimize crop and soil management. Precision farming can be automated considering agriculture parameters to be sensed and the technology needed are listed in the table. So sensing parameters for agriculture are temperature, nutrient, moisture content, soil moisture, irrigation, humidity. Wireless technology used are Bluetooth, Wi-Fi, Zigbee, and radio frequency. Sensor nodes are SHT, 11 temperature or humidity intelligence sensor, and others are listed over here. Now let's see the algorithm for precision farming. Firstly, we specify the sensing area. Then we specify the sensing parameter according to the application required. Apply energy efficient data collection and reliable routing. Perform required action based on decision made on sensed data. Now let's see the cluster-based approach for precision farming, which is that cluster-based routing protocol is the best for an energy-constrained network, as shown in the above figure. The nodes are organized into clusters. The number of clusters specified based on application requirements. Each cluster monitors the respective cluster and collects data from its respective cluster member. Then sends collected data to the sink. The routing protocol based on clustering helps to minimize energy consumption and delay. Now, decision-based precision farming triggers sudden change in temperature, humidity, moisture, and take the following action based on the parameters. Now, let's see the parameters. Parameters are temperature. If temperature is greater than set threshold in a daytime, close top shed net. If temperature is less than threshold, open top shed net. If temperature is
Siddha,
greater than set.
Siddha, can you go for result section?
Sorry, sir?
Results discussion.
Result conclusion. Yeah.
No. Results discussion.
Yeah.
Yeah.
Okay. So here the graph shows the inverse versus delay, where the result in our graph depicts that the case of DCEM and PF-Actin, as the number of data packets increase, the delay also increases compared to DPF. And the precision without cluster-based chooses in advanced congestion-free paths, resulting in minimum delay, even with an increase in packets per second, but is more than DPF.
Okay, fine, ma. What type of sensor you are using for this?
Sensor, sir.
Yeah, from crop you are getting getting some information, right? Through some sensors only we are going to get. So what type of sensors you are using?
Energy sensor, sir.
Energy sensor.
Temperature.
Mm-hmm. We are working with temperature one parameter, humidity one parameter, right?
Temperature, humidity, and soil moisture.
Soil moisture. Okay. Right, ma. Fine. Thank you.
Thank you, sir.
Next batch.
Thank you, Team Shraddha. And our next team is from Manvi Sai Prasanna from Guru Nanak Institution's Technical Campus.
Good afternoon, everyone. Good afternoon, everyone. Sir, is this audible?
Yes, ma'am. You can carry on.
Okay, sir. I am Sai Prasanna and my teammates are Tarun and Nehana. Our project title was Gender and Age Impact on Diabetes Prediction, a Multimodal Approach. Here it is the overview of our project. And coming to abstract, this work explores how gender and age affects individually with diabetes. The aiming is to better understand the various ways these common health issues impact peoples. And here we used random forest, extra trees, and multi-layer perceptron to predict individual diabetic status. Coming to objective, the main objective of this project is to develop a highly accurate predictive model for diabetic status, whether the person is diabetic or non-diabetic or pre-diabetic. Coming to introduction, this work examines influence of gender and
No, go
age
with the
on
implementation.
individuals with diabetes.
Prasanna, go with the
Okay,
implementation
sir.
part as well as result section only.
Okay, sir. Sir, can I explain system architecture?
Yeah.
So here we have collected data set from different laboratories, and then data processing was done for removing any noisy or reduction in data, and then some of the data we have trained it, and other data is for testing. And for training we have used random forest, extra trees, and multi-layer perceptron models, and after that based on their accuracy score we have done prediction. Here these are the result pictures. It is a user registration form where one patient can register through this by giving their details like name and mobile number, gender, age, and their health conditions also.
Okay, what kind of
It
classification
was
model
the
you are using,
login page. If
Prasanna? What kind of
Sir?
classification model you are using, ma'am?
So here I am using three models, sir.
Okay.
Multi-layer perceptron and random forest for classifying.
Random forest classifier. Okay, what type of parameters you are
Yes,
using
sir.
to justify your work?
So based on individuals' age and their gender and also their BMI values and their skin types, etc. Sir.
Right. Fine, ma'am. Thank you. Next batch.
Okay, sir.
Thank you, Team Prasanna. Let's proceed with the next.
Our next team is Anshika Verma from Guru Nanak Institution's Technical Campus.
Good afternoon, sir. Am I audible?
Yeah, it's audible, but
Yes. 1 minute. Good afternoon, everyone. Today, my project is Secret Image Sharing, a comprehensive survey. I am Anshika Balma with my teammate B. Chandana under the guidance of Mr. Arun Singh Kaura, who is the assistant professor in the Department of Computer Science in Guru Nanak Institution Technical Campus. Our project in today's digital world, securing images is really important. Securing images is really important. Uh, and this project,
Anshika, please move to methodology.
Okay, ma'am. The methods used here are data hiding, stegno, encoding, Shami secret rule, and decoding. Data hiding, its main concerns about concealing the image uh, from the within the digital media. Stegno, it uses a steganography technique where the existence of the data image will be hidden for the further process. In encoding, before going to the main thing, the main image will be encoded without disturbing the original image. Original image. This has a various method. In this project, we are using least significant bit method to encode the image, and Shami secret rule also, where the image will be split into various shares. Various shares. And it can be decoded only when all the shares are combined. If any person is having one or two shares, then it cannot decode the image. Uh, this is the execution screenshot. This is our home page, and this is the registration page before any if another new person is login, want to register for them. If already existing, then this is the login page. And here, when we input the image, we have the button called as encode. When we click that, we have to write a
Anshika,
message. Yes, sir.
when you are decoding that image, had you observed any kind of image loss? Had you used or have you worked with any image compression techniques?
No, sir, but in this only PNG images are only valid. If you're using any other form of images, then it's not valid. It's not showing. It's not decoding actually.
No, you are secretly were sending, right? At the second person side, they have to decode, right?
Yes, sir.
Yes. Then, what kind of decoding mechanism you had used?
Uh, for decoding, sir, we have used uh, libraries such as Tegno and Steptix, sir.
Okay, fine. Thank you.
Yes, thank you.
Next batch.
Thank you, Team Anshika. Let's proceed with the next.
Our next team is Abhinaya Reddy from Guru Nanak Institution's Technical Campus.
Hello.
Yes, please proceed.
Okay.
Please proceed, ma.
Yes, ma'am. 1 second. I'm just sharing the screen. So today our topic is 1 second. Ma'am. So today our topic is LRCN. LRCN based eye blink completeness detection. It means while we are driving, when the drivers get drowsiness, so by the eye blink they'll detect that they're closing eyes or they're opening eyes. So that is the project, and our teammates are Nikita, Abhinaya, myself, and Devendra. So now we are going to system architecture. This is the system architecture. In the first step, the data is prepared, and in that we'll collect the images and videos and eye blink detections. And in the second step, labeling is done. Means how much eye is closed, how much eye is open. By the length and the width, they'll calculate it, and then they'll send the messages. In the form of alarm, they'll send the messages. And next, it is trained by YOLO V8 by detecting the faces in accurate real time. And here EAR, that means eye aspect ratio, is calculated in the vertical distance and in the horizontal distance. By the blink patterns only, we would able to know that how much the blink is detected.
Abhinaya.
Yes, sir.
Okay, had you used any image segmentation techniques here in your
Yes,
work?
sir. I've done in screenshots, sir. So in the output, first the login page will be coming.
No. I'm asking about, had you ever used any kind of image segmentation technique?
In our project, sir?
Yes. You are giving inputs, right?
Yes, sir. We have given, sir.
Yes.
Yeah.
For that images, had you used image segmentation?
No, sir.
No.
So,
Yes.
sir?
How your work is going to be justified here? Had you used any parameters or anything?
Sir, we have used YOLO V8 and DLIP techniques, sir, to detect the images like here the eye is open, no, sir. In this, it will show us open 0.82, means how much widely it is open in the points they'll mention, sir.
Okay, we're calculating the distance between two eye-labs, right?
Yes, sir. Yes, sir.
Fine. Thank you.
Okay, sir.
Next.
Thank you, team. Let's proceed to the next team.
Our next team is Sai Teja from Nanak Institutions campus.
Sir, am I audible?
Yes, ma'am. You can carry on.
Good afternoon, sir. I am K. Aishwarya, and my teammates are Varun Gaud and Saiteja. Today, we are here to present on the title of Optimized XG Boost Model for Early Detection of Postpartum Depression, which is a machine learning approach. The overview of the presentation is abstract, objective, introduction, literature survey, existing systems, proposed system, and system architecture. Further will be continued by Varun.
Here I'm going to explain about the abstract, and here the main problem is that PPD is a serious issue. It affects 10 to 20% of the new mothers worldwide, and the tricky part is that it often missed or diagnosed too late, or because of the current methods like the questionnaire ones. So our goal is we want to build a machine learning model that could predict PPD early and accurately using an optimized version of XGBoost. It is a powerful AI algorithm, and how we did it is that we collected data from 1,503.
Can you go for implementation architecture? Implementation.
Okay. So, okay, sir. Architecture.
Sir, coming to the approaches, there are two approaches, sir. One is the existing approach, and other one is the proposed approach. And in the existing approach, we have MKDR, which means meta.
Sorry to disturb you. Please go ahead with methodology. Explain system architecture.
It will be continued by Varun.
In the system architecture, in the step one, we collected the data from various women through Google Forms from 1,003 women, and the questions we covered like age, income, education, and mental health history, and social factors like support from family, stress levels, physical health. And in the step two, we have done the cleaning the data. Like real world data is messy, so we have to fix missing answers, like convert test answers into numbers, and we have to remove some weird outliners, like someone saying they slept 2 hours a night possible. So in the step 3, we used EDA, exploratory data analysis. In this,
can you go for the result section, right? It is okay, fine. Result section. Before
Yes, sir. Yes, sir.
Can you go for result section, ma? Results.
Before conclusion.
There is no result section. There is no result section, right? In your presentation.
Any one of you please respond?
Sai Teja is there?
Yes, sir. I think
yeah. Can you PPT, you had any result section? Your work is good. impressed.
There is
But I
a
need
result.
result section.
Due to network problem, I think she is unable to do it.
Okay, fine, man.
But I
Fine,
can
you can
explain,
leave.
sir. Can I explain it, sir?
Batch,
The
next
approaches.
batch.
Okay. Thank you, sir.
Thank you, Dinashwarya. Up next is
Our next team is Manas Reddy from Guru Nanak Institution's Technical Campus.
Good afternoon, sir. Am I audible?
Yeah, it's audible. Please go ahead.
Good afternoon to all the respected guests, faculty, and fellow participants. We are excited to be here at NCFT 2025. Our project is titled
The
Blockchain.
presentation is not visible, Mr. Manas.
1 minute, sir.
Now it's fine.
So our project name is blockchain-based online social network enhanced with non-fungible tokens. So my teammates are Srija, Mithilesh, Manas under the extreme guidance of Mohammad Irfan sir, assistant professor of CSC. So
Can you go for result? Can you go for implementation part and then results? These two are
yes, sir.
important.
So now my friend Mithilesh will continue.
Good afternoon, everyone. Manas, could you go to the system architecture page? Yeah, I'll just give a brief overview about the NFTs. NFTs are like digital assets. We post something on the online media, like social media, like Twitter. So these are also similar to those posts, but these are digital assets which can have some value. So the architecture
Can you
is
wait for Mithilesh? Can you wait for Pooja, ma'am?
sure, sir.
Pooja, ma'am.
Sir.
Yeah, you people can continue. I will attend this meeting. I'll come back.
Fine. Okay, sir. Okay.
I will collect the marks from you later.
Oh, okay, fine. Okay.
Right. Thank you.
Okay, sir. Yes, Manas Reddy, please continue.
Sure, ma'am. So when a user logins to the application and posts anything on the application, the image is first uploaded onto the application. Then what happens is the image is divided into chunks. And before dividing it into chunks, a hash code of the image is derived, and that hash is saved into the database. Then the image is divided into chunks, and with the help of CDN, the chunks are stored into multiple databases in different locations. So this is called decentralization. So the storage system used for decentralization is IPFS. So IPFS is interplanetary file system. So this is the currently the best storage system for decentralization. So CDN helps. CDN comes into picture before the database or the database systems gateway. This is helpful in managing the traffic which comes from the users. So after storing the images, when a user or the same user or any other user want to retrieve the information or retrieve the image via the application that we have built, so there will be a CID which is unique for every image that will be passed to the IPFS system, and then the image is retrieved from multiple databases. Then it is combined and it is shown to the user. So the advantages of the decentralization is here we can there is no duplicates for this image. So intellectual property of an image or a video is protected through this system. So there can be no duplicates, or nobody can copy one's content in this application. And the other thing is it prevents from data leaks. Since the data is decentralized, uh, even a hacker or an attacker gets the data from a single database, he or she cannot do anything from it, because the data is divided into multiple chunks. So even if there are 2 or 3 chunks with the attacker, the data is not complete. So the main advantage of this application and NFTs is it's unique it's safe, and it is a form of digital asset. Yeah. Manas, can you go to the system requirements? So the system requirements for building this application is the minimum of i3 processor, but i5 or i7 is recommended with 4 GB or 8 GB of RAM, and free disk space of 250 GB. So for front end, we are using J2 EE and servlets.
Manas Reddy,
And
please continue with the result and discussion.
okay. These are the current UI in the application. We are working on the UI. So here we can see that user can upload an image through the UI, and a file from the system can be chosen. And in the right corner, we can see the friend suggestions, like all the social media applications, and below is the friends list. Can you go to next slide? So this is the place where we can find multiple images. So users, artists, and all can post their images here, and other users can buy the images, or if they are free, they can download it from here. Can you move to the next slide? So this is how data is stored. Next slide. Yeah, this is the login page for the application. Srija will continue with the conclusion.
Good afternoon, ma'am. In conclusion, our project presents a modern, decentralized alternative to traditional social media platforms by combining blockchain technology, IPFS, NFTs, and smart contracts. We aim to give users true ownership of their content, ensure transparency, and enable monetization in a secure, tamper-proof environment. Using IPFS for decentralized storage and CDNS for faster content delivery ensures both data integrity and performance. Smart contracts automate NFT creation and transfers, while the reputation system builds trust in the community. Overall, the system not only addresses issues like content, censorship, central control, and lack of creator rewards, but also sets the foundation for a future ready Web3 social experience. Thank you, ma'am.
Okay, ma. What are the functions of NFT, Shrija? Am I audible?
Yes, ma'am. NFTs are like they can be images, or they can be digital arts, like doodles or any art pieces. So they are like images, but they hold a certain value. And like every stock has a price, so NFTs kind of have a price also. So currently the NFT market is very low, but in future, with increase in Web3 and blockchain, NFTs as a whole will grow. But we can't say that a particular NFT can grow or not.
Okay. What are the drawbacks of existing system? How to how you overcome the existing system drawback?
Yes, ma'am. So the drawbacks of the existing system are, one is it's not secured, and the other is there is no uniqueness for the content. So if a creator or an artist creates an artwork and posts it in a social media platform, anybody can take it and repost them. And the other thing is it's not decentralized. So since we are using decentralized, and we are chunking the data and storing in multiple places, it's secure. The other thing is, with every image uploaded into the NFT application, a unique hash key is generated. So since there is unique hash key, so no other person can re-upload the image. So because a hash key is unique, and it prevents it from copywriting, thereby protecting the intellectual property. And it's fast because we use Web3 and blockchain.
Okay, good. Okay, thank you, ma'am. Next batch.
Thank you, ma'am.
Okay,
Thank you, ma'am.
next batch.
Thank you, Team Manas.
Our next team is Satvik Reddy from Guru Nanak Institution's Technical Campus.
Good afternoon, everyone. This is Satvik Reddy from the CSC department, fourth year. Today, I have been presenting my project regarding of the hello.
Yeah, it's audible. Please continue, Satvik.
Yes, ma'am. Today, we have been going to present our project because about railway object detecting using improvised YOLO algorithm with a version of the V8. And let us continue with the overview of the project with the using of the contents that have been abstract and the objectives and the introduction with later with the continuing with the code result and also the system architecture with a few with the ending with the future scope conclusion and the references. As we start from the uh, starting the abstract, the efficiency and the accounting detection for the foreign objects on the railway track is critical to ensure the safety and the smooth operation of the train system. The work addressed the limitation of the existing foreign objects detection method, including the low efficiency and the symbiotic accountants. As in the objectives, we have been safely ensuring that the ensuring the railway safety, as also ensuring the enhancing the detection accuracy, improving the content efficiency, and also the improvising the object recognition, where these four objectives plays in a vital role to have an ensure the safety for the passengers who have been traveling in the train, and also ensure the safety for the goods that have been transported from the one place to another place in the trains. In the introduction, railway transport is an virtual
Sorry to disturb you, Satvik Reddy. Please move to methodology.
Yes, ma'am. The proposed methodological system, on the other hand, introduces the several advantages and addresses these limitations. Instead of the YOLO V3 algorithm, we have been utilizing the YOLO V8, which is an latest updated version of this. It also improves the accuracy, speed, and the real-time performance of the software. The system requires a two-stage approaches, where the first stage is still a low-weight and classified network of the quickly identified objects. In the second stage, YOLO V8 performs the detection and the localization of the objects that are being classified, benefiting. As we have been moving for the code is being represented on this, which is small bit, but the representation of the code has been enlarged version of this, which is utilized by the YOLO V8 algorithm. Thank you. And also, this is the result where you have been able to view that the train which is being identified by the software, and also gives that the prediction of the train that has been shown, and also the railway track and also the wiring will also be objectified view in this program. And also this is the curve that is representing the accuracy level of the confidence, that how that different levels have been represented in this, as this is a following diagram of the pie chart. And also, and the bar values have been represented by this, and it's another view of the picture in the result, where the passengers have been recognized who have been trying to onboard their next train, and also the tracks and the train has also been viewed in this with the accuracy of the 0.95 percentage, and also the persons who have been standing on the platform with the 0.72 percentage. And this is a performance gallery where the accuracy and the consistent matrix normalization will be performed without any error that have been showed in this. This is the system architecture where the input is being given in the pictorial form, and the backbone is a conventional method from the CF2 to CFT3's methodologies has been given presented. In the neck bound, we have been the bounded structure of the content which has been detected, ma'am. And in the future scope,
Sorry to interrupt, your audio is getting stuck.
in the future scope, which has been the proposed railway objects have been instruction detected for the system to demolish the significant improvements in the both accurate and efficiency way. In this, the YOLO V8 algorithm, which has been playing a vital role for the improvised structures, In the references we have been taking these all references from the IEEE structures and also the journals which have been laterally published before us. This has been represents. Thank you.
Yes, Satvik Reddy.
Yes,
Satvik Reddy, am I audible?
Yes, ma'am.
What are the parameters you have considered to calculate the accuracy? How much percentage you got the accuracy?
Ma'am, the accuracy has been behaved of the 90 to 95% before, and the based on the what kind of the input we have been given to the algorithm, ma'am. In this,
Okay.
the algorithm.
Yeah. What type of data you have given as an input to the model?
Ma'am, the data which has been provided, this is in the pictorial form and also the visualized form, ma'am, where the cameras which have been captured the entire system is being provided for this, where the it also analyzes the risk factor also, ma'am, where it reduces the accidents prone, ma'am.
What is the size of the data you have considered for input?
In the size has been measured in the terabytes, ma'am. Also, the size is being reduced or also been increased whether the size will be decreased when the content that has been produced as an input will be less, as also will be increased whether it has been also more, ma'am.
Okay, fine. Thank you. Next batch.
Thank you, ma'am.
Gayatri. Yes, next batch. Yes, next batch. Yes, Gayatri. Ocean.
Ma'am, shall I call next team, ma'am?
Yeah, ma'am. Continue.
Our next team is Aditya Srivatsa from Guru Nanak Institution's Technical Campus.
Good afternoon. Good afternoon, ma'am.
Yeah, good afternoon. Please proceed.
Good afternoon, ma'am. Today we are here to present our project detection of hand-bone fractures in X-ray using hybrid YOLO. So this is our overview of our project. And coming to the abstract, our project enables us to detect the hand-bone fractures in the real time, which is a very great spectrum in the field of medicine. Previously, we used to use YOLO NAS, which is a neural architecture search, but we have overcome all the disadvantages of it, and we are offering the new model of YOLO V8 in detection of hand-bone fractures. We are using a dataset of 1200 hand-bone X-ray images to classify into 6 types of fractures, which which our machine learning model can detect. And objective of our project is to develop and to create a project which is so advanced that we could use it in a real time, and which can be taken out, and also which can be a mobile application, so that common people can also make a use of it and diagnose if there is any emergency. So introduction of our project is timely and accurate bone fracture detection is essential for effective treatment and preventing complications, because even now doctors can't even, with a visual spectrum, can't even detect a tiny bit of minute airline fractures. Our project helps doctors and also common people to even detect a small minute airline fractures, and also help them diagnose it way better than leaving it apart. existing model is YOLO-NAS, which used to struggle with the accuracy and also speed and also the compatibility with every model which have been updated. So YOLO V8 is used to achieve higher accuracy, higher speed and efficiency in real-time medical image analysis. So as I said before, our data set is included with 1200 hand bone fractures, which includes fractures of fingers, fracture of the middle joint femurs, and also the tendons which join the bones together. So YOLO V8 outperforms YOLO NAS in many different ways, and also which it can be compatible to any mobile device or any fully developed devices. And existing system, Manasa.
In existing
Yes,
system, we use
Aditya, please explain a proposed methodology.
Yes, ma'am.
in proposed systems, we use YOLO version 8 as a proposed system. Here it is a
Can you
combination
share the screen? Sorry to disturb you. Can you share the screen, please?
Is it not
Yeah.
visible here, ma'am?
Yeah. Now it's visible. Please proceed.
Yeah.
Yeah, ma'am. In proposed system, we used version 8 of YOLO. Here, it is a combination of YOLO NAS, efficient detection, and a DET R3. These three are the existing system algorithms. By enhancing these three algorithms, we used YOLO version 8 as a proposed system. The core features are detection fractures, optimizing YOLO NAS, and implementing efficient detection, integration of detection of R3, and training the model. In advantages of YOLO version 8, by improving the accuracy, fostering the detection, enhancing the precision, and greater generalization. System architecture is here it tells about the data set. It transfers the 80% of the data to the training set. Here, this training set will train the YOLO version 8 of algorithm by extended training set, by data augmentation, where we will label the data of the set, and 12% of the data will given to the validation set to validate the algorithm. This YOLO version 8 algorithm will evaluation will be happened over there, and it will transform to the testing set. This testing set will give the output as what type of fracture it is, and where the exactly the fracture happened, and with the exact weight. And also it compares with the YOLO NAS by comparing the accuracy and precision. Future enhancement result. Here, this is the first figure showing the home page, and second figure shows the login page where we need to register and login. And in the third figure, we need to choose a file as an input and upload an image to the upload an image for YOLO detection. Here, in last figure, which shows that it is a bonded box over there detecting the where exactly the fracture happened and what type of fracture it is, and with the accuracy. Future enhancement.
Good afternoon, ma'am. While our current model shows promising results, there is room for future improvements and expansions, like larger diverse dataset. This means we train the model with more X-ray images from different peoples, like age, genders, and fracture types, so it can work well for everyone. 3D image integration. We use 3D images like CT scan, MRI scans to help the model see fractures more clearly, especially tricky or deep ones. We use pre-trained models start with model that already learned from the big data sets to help the system detect even small or hidden fracture better. And mobile application. In this, we make a phone app that can be accessible for everyone, so that they can upload an image and they can identify the type of the fracture that occurred to their hand bone. And personalized and adaptive learning. Let the model learn from the patient history and new cases over the time, so it gets better and more accurate as it's used. Conclusion. By this, we can conclude that a hybrid YOLO-based model was developed by detecting hand bone fractures in X-ray images. This model combines the accuracy and the speed of YOLO with enhancements suited for medical imaging. And this experiment shows high precision, recall, and real-time performance. In this, we use 1200 well-prepared X-ray images and smart data processing. The model achieved strongly accuracy. This approach can significantly assist radiologists by reducing diagnosis time and increasing accuracy, especially in the emergency time. Here are the few references that supported our work, including key research papers and previous studies related to the bone fracture detection and YOLO models. Thank you, ma'am.
Yes, from where you have collected the data set? Am I audible?
Hello, ma'am. Am I audible, ma'am?
Yeah, audible, beta. From where you collected the data set for your project?
Ma'am, we used public available medical images data set, ma'am.
Okay, can you mention any websites or any social media from where all you can collected the data sets? As you said,
Ma'am,
1200 X-ray images.
yes, ma'am. We have downloaded all those images from HIPAA, HIPAA.
Okay, good.
Which is a medical journal, actually.
Okay, fine. Okay, how much precision and recall percentage you are getting?
82.5%, ma'am. 82.5 with 82.5 with HD images.
Okay. What about F1 score?
Sorry, ma'am.
F1 score.
Hello.
Hello, am I audible?
Yes, ma'am. F1
What
score.
about it? Yes, F1 score result.
Actually, we haven't tested in the F1 score. Sorry for that.
Okay, fine. I think you consider precision and recall.
Yes, ma'am.
Okay. Have you considered the confusion matrix?
No, ma'am. Actually, we will calculate the F1 score. We mainly focused on the accuracy and also the timing. We haven't
Okay.
gone to the other metrics right now.
Okay. Okay. Thank you. Next match.
Thank you.
Next match.
Our next team is Mukita from Guru Nanak Institution's Technical Campus.
Good afternoon, ma'am. Good afternoon, ma'am.
Yeah, good afternoon. Please proceed.
Yeah. Good afternoon, everyone. We are really happy to be here today. Present our project title "Fake News Detection Using LSTM with Fuzzy Logic." Let me introduce our teammates. Me, Mukita, and my teammates are Arvind and Shravan. So now I'll go with the abstract. Abstract, the project focuses on solving the problems of detecting fake news. Normally, this job is done by human experts, which is slow and sometimes uncertain. In this work, we use a smart deep learning model called LSTM, means long short term memory, that is good at understanding long sentences and text. We trained our model using the LAR dataset, which is commonly used for fake news research. Our model showed 99% accuracy, which is a very high result. Next objective. The main goal is to build a better fake news system using LSTM with fuzzy. The systems handles uncertainty better than old methods, performs better than CNN BLSTM models. Next introduction. Fake news spreads quickly and can mislead people. This usually ways to detect fake news are slow and depend too much on humans to fix this. We use LSTM networks, which are good at working with text and understanding the meaning of sentences. We add fuzzy logic to help the model deal with confusing or unclear information. This system is trained on the LAR dataset and gives very good results, making it useful for real world use. The next will continue, Shravan.
Mukita, sorry to disturb you. Please continue with the methodology.
Ma'am?
Please continue with methodology.
proposed methodologies. NLP and BiLSTM is used in this model. NLP is defined as natural language processing. It is a branch of AI that allows computers to communicate with humans using everyday language. It helps machines understand, interpret, and even generate human language in a way that feels natural and useful. And BiLSTM is defined as bidirectional long short-term memory. It holds sentences which is very long. A major breakthrough in NLP is the use of LSTM networks. LSTMs are a special kind of recurrent neural networks designed to remember important information over long sequences. Next, Arvind will continue.
The existing system. So in this existing system, we have used CNN, that is conceptual neural network, which is used for the features for the input. So in the input, we use the bidirectional long short-term memory as a hybrid neural network architecture that combines CNN and bidirectional short-term memory. So
Please explain methodology. Existing system not required.
Yeah, okay. So proposed system is which is used by the long short-term memory and the NLP as a natural language process, which the input is taken by the NLP and which is processed by the NLP. And with that, we use the fuzzy logic for the input like the values of 0 and 1, which are used by the fuzzy logic. So by using this, we can like using the recurrent neural network, we propose the model. So it will like give the output with 99% accuracy. So after that, the result, this like a system architecture, in that we use data pre-processing. So for data pre-processing, we use the NLP method. So after that, the sequence of the sentence which are taken for the input, which is used by the LSTM. So the fuzzy logic is used for the final classification of the data. So as per the result which is given by the LAR dataset, so demonstrate the performance of the existing CNN and by LSTM. So in the conclusion, in that conclusion, we show that the effectiveness of NLP technologies, which is LSTM and the bidirectional LSTM, which is used for detecting fake news, which is the input is a text pattern or any other like text or the human mimicking languages like text or the context like true or false or something, the data which has taken, it detects the accuracy of the so which is in a real-time detection and explainable by the AI. So overall, the project provides a strong foundation for future research and development in fake news detection, contributing to the more accurate, transparent, and scalable solutions. That's it.
Yes. You said future researcher in fake news detection contributing to the creation of more accurate and transparent and scalable solution to combat misinformation, you said, right? Okay.
Nice.
How you can say that the fake news detection can give the more accurate results? For example, in Facebook or in social media, let's say, for example, I'm the user, I may send a number of fake news. How you can identify which one is the accurate one?
Yes. By using we use several strategies like technologies for that. By using LSTM sequential text understanding, we can use that, ma'am. So LSTM is long short top memory network, which is a great at learning of long range dependencies. So by using that text, we can understand the like we can get the accuracy of the fake news, ma'am. So by using another one is also there like a fuzzy logic, which is like numerical value 0 or 1, truth or false value. So by using this technology also, we can detect the fake news using LIAR.
Okay, thank you. Next batch.
Thank you, team Rukita. Our next team is Sriram Reddy and team from Guru Nanak Institution's Technical Campus.
Good afternoon, ma'am. Just 1 minute, ma'am.
If they are not ready, please announce the next batch.
Yes, ma'am. We are ready, ma'am.
Okay, please continue.
Yes. Good afternoon, ma'am. Myself, Akhil, and Sriram Reddy and Pawan are my teammates. Our project title is Liver Cirrhosis Stage Classification. In this, we use LivMarks as AI model, and instead of traditional imaging techniques that helps doctor determine how advanced liver cirrhosis is based on patients data. Yeah. Next slide.
Please move to the proposed methodology. Yes.
Our proportional concept is we use neural networks that can learn patterns from data, like we use CNN and RNN. RNN is used for RNN stands for recurrent neural networks, and it stores previous data, and it stores the data so that it can be helpful in the future purposes. And CNN deals with images and later. RNN also process. And proposed system advantages are it can transfer learning. Hello.
Pawan, voice is not audible.
Hello, ma'am.
Yeah, please proceed.
Yes, ma'am. Here we in this proposed system we use LivMarks as our training model, and it possesses of 87% accuracy. Instead of imaging, it uses blood test results and other biomarkers to identify the liver stage, whether how bad the liver is damaged according to the AI model. And system architecture is first we will insert the images of the liver. Then the first step is data processing. In this step, the unwanted data is removed in this stage. And the second step is data partition. In this stage, the data is divided into smaller. The data is divided into smaller particles so that it can be subsets, so that it can be executed easily.
Okay, next, explain result and discussion. Yes, please proceed.
Yeah, like this. In this we input the information like how bad the liver is, like liver images, and the stages like blood samples and blood percentage that.
Yes, Pawan, from where you collected the data? Am I audible, Pawan?
Yes, ma'am. Yes, ma'am.
What type of data you have collected?
Like patients liver images from Mayo Clinic.
Are you collected any real-time data set?
Yes, ma'am.
Okay, how many, what's the size of your data?
Like it can be a one image or just multiple images.
I'm not asking you one image or multiple image. What's the size of the data which you collected from hospital? You're saying that the data is of real time.
Yes, ma'am.
Why you got the accuracy is only 87%? It's very less, right?
It's from KB to 1 KB to MB.
Is it sufficient for training and testing the data? Okay, for training and testing, how much ratio you are given? Okay, ma. Thank you. Next batch.
And we have our last team, Vikyat from Jyoti Institute of Technology.
Hello, ma'am.
Yes, Vikyat. Please continue.
Yeah, 1 minute, present screen.
Vikyat, please proceed. Yes, Vikyat, please proceed. Yes, Gayatri. Vikyat, am I audible?
Vikyat, are you there?
Yes, ma'am. Yes, ma'am. 1 minute, ma'am.
Vikyat, please join. Vikyat, are you there?
Yes, ma'am.
Please proceed.
Vikyat, are you there? You are presenting or not?
Yes, Gayatri. Vikyat, are you there?
Ma'am, we'll call another team member.
Okay.
Our next team is Jan from Guru Nanak Institution's Technical Campus.
Ma'am, am I audible? Hello.
Yes, Gayatri, please call next batch.
Team Jen, please present.
Yeah, it's audible. Please proceed. Yeah, please proceed.
Our project is about small healthcare monitoring system using mobile application. So what we do is actually we make a mobile application using Kotlin and Java. So for that we are just using to create UI designs, Kotlin and Java. After that, the main use of this healthcare monitoring system is to tell about what they are doing. So there are many disadvantages in regular applications, like they'll not monitor regularly, and so our application with monitoring. So in some cases, they are then count steps, but they're not count the list. But in our application, we are calculating both distance and steps. I know.
Yes, it's audible. Please proceed. Move to the methodology. Yes.
That's what we are doing is we are starting. We'll open the application. Then after that, how we track all this is first we'll count how many steps the human is doing, and we'll calculate the distance. After that, how this just, so after that, we will show this in form of lesson. So you can easily identify this. So this will make this rich. So this is the procedure.
Shrikant.
So
Shrikant.
there are advantages of yes, ma'am. Yes, ma'am.
So, how we are overcoming the drawback of the existing system in your project?
So what we are doing? So that is what I'm telling.
So mainly in many applications, they will just count the steps, ma'am. But in our application, they'll count the steps. And also the systems that limits that is quite like this actually. So we count the steps. We have application, we must count steps. And we also count the steps that is traveling. So in the here we can perfectly normally steps on the steps in normal they just count the steps. On the count steps will be counted even if you have to just for family any regular
Shrikant, please proceed.
No, I'm telling them.
Your voice is not audible to me.
Now is it audible now?
Yeah, it's audible better.
Okay, ma'am. So in regular
What's the
applications,
advantage of your project? Listen 1 minute. How best you can say that your project is good? How you are justifying?
So, ma'am, that's what I'm telling you, ma'am. So, in order to make the calculation accurate, how many steps the user or how much distance the user is carrying. So, we'll first track the steps, and then we'll calculate the distance, and also we'll calculate the speed. If the speed is about 20 or 30 na, no, and human cannot go about 20 or 30 na, ma'am. So that refers that he's on a vehicle, ma'am. So it will not count any steps. So we'll having that some what conditions. Only if that conditions it will accept, then we will be calculating the steps, ma'am. Otherwise, we'll not calculate it. After calculating everything, we will be getting accurate information. This all will be stored in cloud. So after this cloud, after storing it, everything will just show the user in the form of graphs. In basic applications, they will show only in the form of normal number systems now. So they cannot. Some users may be easy to use. Some users may not use it easily. So in order to make it easy to use, we'll use graphs, and etc. These graphs are converted. Graphs can be stored through using Power BI. So the entire data will be stored in cloud, and then this data will be used to convert the normal data into graphs, so the user can easily understand it.
Okay, Nana. Thank you.
Okay, ma'am. Thank you.
Next batch.
Now I would like to call faculty coordinator for vote of thanks, Mr. K. Shankar.
Yes, Vikyat, are you there?
Yes, ma'am.
Are you ready to present?
Yeah, ma'am. I'll present.
Please continue.
Hello, good evening, madam. Madam,
Yes, good evening.
madam, my presentation is also not completed, madam. So the madam saying that vote of thanks,
Ma'am, 1 minute. You be the line. Vikyat, you please continue.
Uh, Good afternoon, ma'am. My name is Vikyat. I'm from Jyoti Institute of Technology. So our project deals with image captioning. Uh, image captioning through speech, text to speech, and speech generation. It uses deep learning models to generate a textual description from an image and then converts the text into spoken audio and uses text to speech engine. So, what the key concepts used in this uh, project was image captioning and text to speech. So, it merges computer vision and natural language processing with speech synthesis. The project demonstrates how machines can use and see, understand, and speak. So the problem set was the visually impaired people could not understand what's there on the screen, the image. So through this project, they could understand what's there in the screen and visualize. They could understand what's there in the screen, and so the objectives were making an automated image captioning system using CNN and LSTM, and add a text-to-speech system and generate a natural sounding audio. And design a user interface for the visually impaired people so that they could upload images and view captions and hear the audio, and optimize the accuracy and response time for the for the users. The
Sorry to disturb you, Vikyat. Please present your slides. It's not visible. Yeah, okay.
So
I am also from Jyoti Institute of Technology only, and I will continue from here. And this is the implementation part where we basically take the input, that is, if we upload any image, then by using the CNN, it basically extract the features from the CNN by using the CNN pre-trained models, and then those extracted features will be transferred and formed into a vector representation. And then those feature transform, which are the transform, those will be by using the embedding layers. If whatever the picture they uploaded, if it consists of any if consists of any textual data, then it will be merged by using the embedding layers, and then those all the textual features and the verbal features, those will be combined together and then passed on to the LSTM model. This is LSTM model is a long short-term memory model. It basically helps to predict the sequences in a proper order so that it will give the, for example, if you upload a image of a cat playing with a ball, then it will say the cat is playing, then it will predict the line with the ball, like that it will predict. Next slide. Next slide.
Next, resultant discussion.
in the results and discussion, this is the web page we used. So
show me the graph.
Ma'am?
Please move to the slide.
This slide, ma'am?
No, it's not visible. Only implementation side is visible to me. Yeah, next. Yeah, now it's visible. Please proceed.
So this is the web page we used. So here there's a command like take picture and upload image and generate caption. So the visually impaired people could take if they put a command like take picture. So the computer analyzes the voice command as take picture, and it takes the picture and analyzes the photo and generates a caption for it, and it generates the caption and converts it to audio and tells what's there on the in the image. And in the future developments, we are going to use Google text to speech and add more languages so that it could be multilingual, and the translated caption can be displayed along the original making system more inclusive and globally usable. So, in conclusion, the SnapSense helps the visually impaired people so that the images, the visually impaired people can understand the images better, and they can upload and get to know what's there on the screen and through camera.
Okay, good. Like, have you used LLM model? Have you used any LLM model?
We used LSTM model, ma'am.
Okay, good.
Yeah.
How much accuracy you got?
Ma'am, we got approximately 92 to 93% accuracy because we used Python text-to-speech engine along with it. If you could use Google to text-to-speech, then it would be more accurate.
Okay, okay, fine. Okay, good. Thank you. Next question.
Thank you.
Is there anyone left to present their PPT?
Yes, sir. Chitrarupa, madam.
Yes, madam.
Please proceed.
Okay, madam.
Chitrarupa, can you please share your paper ID?
Okay, madam.
Chitrarupa, madam, please start the presentation.
Okay, madam. Everyone.
Excuse me, Chitrarupa, please can you respond?
Yes, madam.
Please tell your paper ID.
Madam, Ncft 188, madam.
No, you're not in our session.
Madam, I am calling that another madam. It tell me you are in a session 5, madam. That's why I'm waiting from 2 o'clock. I'm waiting in this session, madam.
Okay, continue. Okay, madam, continue.
Okay, madam. Good evening, everyone. Myself, Chitrarupa, working as an assistant professor in Sri Venkateswara College of Engineering, Department of CSE. Now I am presenting a paper on image-to-text summarization using DITE and GPT-2. So in this, I am presenting the paper. My agenda is abstract, introduction, literature survey, methodology, conclusion, and references. So this is the abstract for our paper. So visual summarization framework for a medical image captioning system that leverages a data efficient image transformers as visual encoder and GPT as language decoder within a encoder decoder architecture. So in this, I utilizing this data efficient image transformer as the adopted for processing to extract and gain visual information from the medical images. So that medical reports are transformed into text embeddeds, and also they have to generative pre-trained medical images. So we have to retrieve the information from that medical images. So in this, we have to given the training to, so the reports are transformed into text embeddeds, and also the GPT-2 model is used as a decoder to generate medical reports. So our model utilizes a cross-attention mechanism between vision transformers like that. That means data efficient image transformers along with the GPT-2, which enables it to create and define the coherent medical reports based on visual information extracted by the encoder. So in this, our model, we have to extended the report generation with the general knowledge, which is independent, and also it can be provide comprehensive report in broad sense. So in this, we have to utilize our objective is to improve clinical text generation by summarizing visual diagnostic data into concise and semantically meaningful captions. So the evolution is standard natural language summarization metric we have to utilize it. So rogue values. So in this we have to get the result as 0.06 as the blue value, and also 0.27, 0.09 and 0.22 as the longest sequence of the rogue values. So in this work we have to demonstrate potential integration vision transformers with auto. We have to give the AI assistant radiology reporting systems. So this is the introduction of the system. So the increasing volume of the medical imaging data, necessarily they have to explanation of automatic tools that assist radiologists in their workflow. So in this, the transformation based architectures such as vision encoders and large language models have demonstrated remarkable capabilities in understanding and generating complex data. So this paper presenting the implementation of vision encoder decoder model, leveraging the pre-trained.
Madam, sorry to disturb you. Please move to the proposed work methodology.
Okay, madam. So in this, we have to propose the methodology as the encoder decoder.
Ma'am, please. Hello.
Madam.
Ma'am, slide is not visible.
Madam.
Ma'am, yes. Please share your screen, ma'am.
1 minute, madam.
Yes, ma'am, please continue.
Okay, madam. So this is the methodology of our system. So in this, we have to take in the data set from the Indiana University chest X-ray data set, which can be having the large collection of chest X-ray images and their corresponding radiology reports also. So the data set includes the two primary CSV files, Indiana projections and Indiana report CSV files, along with the nearby 7,310 medical report images according to the X-ray reports is there. So we have to utilizing these X-ray reports. So the model architecture which can be consisting of encoder. So we have to use it is the data efficient transformers. It is the diet, and also we have to utilize the decoder as the GPT-2. So vision encoder decoder model. So in this, the data have the capability of they have to generate the captions by using of medical images. So in this, we have to utilizing these type of visual encoder decoder model when we have to generating the captions from the medical images. So the vision encoder decoder model. So in that we have to given the input image as the X-ray image, and also we have to given the training like this. So these are the CSV file which can be having the abnormality which can be existing in the radiology report. So it is the two, each patient having the two medical images. So which is the frontal and which is the lateral X-ray image. So we have to given the training by both lateral X-ray image captions and along with the frontal X-ray report captions. So we have to given the training on this data set. So finally, automatically we have to given this training. Finally, we have to get this type of output. So generated the captions. So the lungs are clearly. So in this, we have to clearly visible like as so this is the X-ray image. So lungs are clearly bilaterally, no focal illiterate. This is the generated caption for this image. So we have to given by the encoder, we have to take the medical image as X-ray image, and automatically they have to generate the captions like this. System architecture. So vision encoder auto feature extractor. So vision encoder decoder model we have to extract the feature from the right model, and sequence to sequence trainer is also there. So along with this, they have to generate the captions. So according to the results, so they have getting the blue value as 0.080%. We have to compare it with this value in the with GPT-2. So this reference paper is also is there. So we have comparing our proposed model to this model, but a little bit variation is showing in this result. But our implementation, they have to having this type of experimental results. So the quantitative results of this evaluation, including the average, blue, rogue, and rogue 2 values. So the meter have score obtained by the training data set. So in this graph, they clearly visible the little bit improvement we have to get from the already existing WIT model. So in that model, little bit improvement they have to get they have to generate the report from the medical reports. So finally, we have the conclusion. This paper presents a practical implementation of vision encoder decoder model, which can be used the diet and GPT-2 model. So, but a little bit improvement is there, but our convenience. So we have to go for the implementation of these models. So these are the references for this model. Thank you.
Yes, thank you, madam. Over to sir. Sir, please. Sir, you're muted.
Hello, am I audible, ma'am?
Yes, sir, it's audible.
Yeah. It's done?
Yes, sir.
Okay, fine.
I now welcome our respected session chair, Dr. P. Naresh, to share their feedback.
Yeah, good evening, all. Regarding to this conference NCFT 2025, here maximum whatever the papers which are printed by various people across the India, those are good, and which covers machine learning, artificial intelligence, deep learning techniques, and they have shown their good results by means of some kind of statistical methods. Statistical analysis was done, and I'm thanking you all.
Thank you, sir. Thank you, sir. And now I welcome our respected internal chair, Ms. Pooja Kulkarni ma'am, to share their feedback.
Yes, good evening, one and all. I want to say thanks to all the participants for your valuable Thanks to all the participants for your hard work and valuable time. Really, it means a lot to us, and you have done very hard work. And I'll say thanks to all the participants. Definitely, you'll support in the next version of our conference. Thank you, one and all.
I now welcome faculty coordinator Mr. K. Shankar for vote of thanks.
Good afternoon, everyone. I am Shankar, faculty coordinator of NCFT. As we come to the close of this enriching national conference on futuristic technology, I extend my heartfelt gratitude to each one of you who made this event a grand success. A special thank you to our esteemed session chair, Dr. P. Naresh sir, and our internal chair, Ms. Pooja Kulkarni ma'am, for guiding the proceedings with such grace and insight. To all the paper presenters and delegates, your contributions, perspectives, and innovative ideas have truly elevated the discussions and inspired us all. We are deeply grateful to our institutional leadership, the organizing committee, sponsors, and the dedicated volunteers whose behind the scenes efforts ensured everything ran seamlessly. Let us view this moment not as a conclusion, but as the beginning of new collaborations, continued learning, and a shared moment to shaping the technological future. Thank you all. Thank you, Naresh sir.
Yeah. Thank you, Shankar. Thank you, Pooja ma'am.
Okay, sir.
Thank you, sir.
Yeah. I will contact you later.
Sir, we will meet you soon in next version of national conference or international conference.
Sure. Thank you very much.
Thank you so much, sir.
Yes,
Thank
thank you,
you,
Shankar
sir.
sir. Bye bye.
Okay, sir.
Thank you everyone for joining us today. Have a great day.
Thank you all student participants also.
Yes, ma'am.
Thank you. Well done in anchoring job also. Good.
Thank you, ma'am.
Thank you. Bye.
आप उनको बोलना ना जी थैंक यू